So Mr. Sarthak will be doing volume of prism. Now, what you need to understand is that when you look at figures like these, so this figure, this figure, this figure, this figure, Mr. Sarthak, do you agree that this side? If you look at this figure from this side, let us assume you look at from this side. This is your eye, and you are looking the figure from this side. Do you agree, Mr. Sarthak, that when you look at the figure from this side, this figure is symmetrical? Mr. Sarthak, do you agree?
Yes.
Mr. Satya, do you agree?
Yes, sir.
So similarly, when you look at this figure from this side, let me draw this is a rough diagram of an eye. So this is how, if you are looking towards this side, so this face is symmetrical to this face, would be symmetrical to this face. Can you see that? What I'm trying to tell you guys?
Yes, sir.
Mr. Sarthak?
Yes.
So similarly, when I look at this figure from this side, when I look it from here, again I'll see that this figure is symmetrical on this axis, and here also it is symmetrical. Do you guys agree?
Yes, sir.
Mr. Sarthak, do you agree?
Yes, sir.
See, I'll try to explain it like this. I think now you will be in a better position to understand. See, when I look at this figure from this side, let me assume that I am looking from, there are two angles in which I can see this figure. One is I can look at this figure from this side. The other way is that I can look at this figure from this side. Have you understood what I said?
Yes, sir.
Mr. Sarthak?
Yes, sir.
So when I look it from the left side and when I look it from, say, bottom, or even if I look at this figure from top, and I can look this figure from the right hand side also. Now, what I'm trying to tell you guys is that in both these cases, when I look at this figure from left hand side and from the right hand side, and compare this when I look it from top and I look it at from bottom. See here, you will agree that I will see this figure like all these circles which are concentric to each other. Have you guys understood?
Yes, sir.
Mr. Sarthak?
Yes, sir.
But the problem is when I look at this figure from left side or the right side. The point is when I start, let us assume that I start slicing this figure. I hope you are able to understand what I'm trying to say. If I start slicing this figure, I take a blade and I start slicing the figure like this. I start slicing the figure like this. I hope you are able to understand that the area of the slices of all these slices would differ. Are you able to understand this? Not able to understand this?
Yes, sir.
Mr. Satya, any problem? Should I explain?
No problem, sir.
So what I'm trying to tell you guys is that if you see, there are two ways. Okay, another way I can try to explain this is there are two ways in which you can slice the cylinder. So let us assume that we want to slice the cylinder. Slice the cylinder. I think that this would be a bit easier to understand. So I can slice the cylinder like this. I can make slices like these. Have you understood that? Have you guys understood?
Yes.
Yes, sir.
Now, when I'm making slices like these, I will have these circular slices. Do we agree to this or not?
Yes, sir.
Yes, sir.
But let me show you another way in which you can slice the cylinder. So another way in which you can slice the cylinder is you can slice the cylinder like this. Have you guys understood?
Yes, sir.
Mr. Sarthak,
Yes, sir.
do you agree to what I'm saying?
Yes, sir.
So whichever way you are able to understand, one way of understanding this is if you look at the figure from top and above, then you will see circles only, concentric circles only. But if I see it from left and right, the slices that I will get won't be equal. Do we agree to this?
Yes,
Yes,
sir.
sir.
Okay, one second. Okay, so why I require two ways of slicing the cylinder is because if I want to find the volume of cylinder, one way in which I can find the volume of a cylinder is that when I look the cylinder from this side, I know that all these slices of the cylinder would be equal. Mr. Sarthak, do you agree?
Yes, sir.
Now I know that the area of one slice is pi r square. Do we agree to this?
Yes, sir.
And this is the height of the cylinder. Therefore, volume of cylinder would be equal to the area of one slice into height. Do we agree to this or not?
Yes, sir.
Mr. Satya?
Yes, sir.
See why this is important to visualize this because then if you buy this argument, then another way of looking at a cuboid or a cube, both of them are same. Another way in which you can look at a cuboid or a cube is okay. Yes. Now let me look at this cuboid from the bottom. Let us assume we are looking at the bottom only. If you agree, all these slices would be equal. Do we agree to this? All these slices would be equal. Now if this is the length, this is the breadth, and this is the height, area of one slice that I am looking at, area of one slice that I am looking, this area is length into breadth. Mr. Satya, do you agree?
Yes, sir.
Therefore, volume of the cuboid would be equal to length into breadth, which is the area of one slice into height. Do we agree to this? Mr. Sarthak, Mr. Satya.
Yes, sir.
Yes, sir.
Now, if you buy this argument, then as a matter of fact, I can have a prism like this. I can have a prism like this. Now, let me know if you are comfortable with this or not, or I can perfectly explain this in detail. So, let us assume that we have a prism like this. Let me draw this. Let me draw this like this. Okay. So, this is one end, and this is the another end. Are you able to understand?
Yes, sir.
Mr. Sarthak?
Yes, sir.
So, I think this is what I'm able to draw. Yeah, I think now it is making sense. So, do you guys agree that if I have a prism like this, and I'm looking at this prism from this angle, again, these slices are equal, all these slices are equal. Do you agree?
Yes, sir.
The area of one slice, if you remember area of this face, let us assume that this is a triangle like this. So, area of one slice is half base into height. Do you agree?
Yes, sir.
In this case, let me assume that this is base and this is height. Mr. Satya, is it okay?
Yes, sir.
So I am able to find the area of this slice. Area of one slice is half base into height. Now, if this is the total length of the prism, then the volume would be equal to half base into height whole multiplied by L. Do we agree to this? We don't agree to this. We have a confusion. Mr. Satya, Mr. Sarthak,
Yes, sir. Okay. I understood.
Mr. Satya.
Understood, sir.
See, if you guys understand till here, then what I'm trying to tell you is you can have any figure. You can have maybe a prism where the both ends are, let us say that the both ends are trapezium. Have you understood what I've said? Have you
Yes,
guys
sir.
understood what I've said? Mr. Satya,
Yes, sir.
Mr. Sarthak,
Yes, sir.
you can have a figure like this where both ends of the figure are prisms. Can you see this prism? Can you see that these are trapezium? Can you see this?
Yes, sir.
And let us assume that you are looking at this figure from this angle. Mr. Sarthak, are you able to see?
Yes, sir.
I hope you are able to see that each cross section of this prism would be a trapezium. Any doubt till here?
No doubt, sir.
Mr. Sarthak, any doubt? Mr. Sarthak, any doubt?
No, sir.
Now, do you guys remember what is the area of a prism? Can you tell me the area of this prism? Sorry, area of this trapezium. You can look at your notes here. You can look at your notes. Yeah, Mr. Satya,
So A plus B upon 2 into H.
Mr. Sarthak.
Yes, sir.
What is the area of a trapezium?
So A plus B upon 2 into H.
Is it half a plus b into h?
Yes, sir. But that can also be written as A plus B.
No. So what is the formula of a trapezium? Area of a trapezium, Mr. Satya.
So 1 upon 2 A plus B into H.
Do we have any confusion, Mr. Sarthak? Do we have any confusion regarding this?
No, sir. I said that.
Okay. So now area of each slice is half a plus b into h, where h is the distance between the two parallel sides. Now, if this hole is L, do you guys agree that volume of this figure would be equal to half a plus b into h whole multiplied by L? Do we agree to this? Do we not agree to this? We haven't understood this.
Sir, I didn't understand.
I'm sorry, you haven't.
Yes, I didn't understand.
Okay, Satya, Sarthak,
Yes, sir.
any problem?
No, sir.
Okay, Satya, see, what I'm trying to tell you is that starting from this figure, now let us relook at all the things that we have done. Let us start from here. See, what we have done, Satya, is we take a slice. We look at the figure from an angle where it is symmetrical. We take the area of the slice, then we multiply the area of the slice with the length of the side in which it is symmetrical. Satya, have you understood?
Yes, sir.
So basically this slice, and h actually is the length of the side in which the figure is symmetrical. Satya, any doubt?
No doubt, sir.
Then, one second. When I had to find the volume of the cuboid, this was a slice which is symmetrical at this length. Satya, have you understood?
Yes, sir.
So area was L into B, and then I multiplied by the length of the side at which it was symmetrical, which was h, and that is why this h came here. Satya, any doubt?
No doubt, sir.
Now when I had to find the volume of a figure like this, I found the area of this slice. The area was half base into height. Then I looked at this figure from this angle. I multiplied it by the length of the side at which it is symmetrical. Satya, any doubt?
No doubt, sir.
So this is half base into height multiplied by L. Any doubt?
No doubt, sir.
See, what you need to keep in mind is that please do not get confused that whether this is H. Okay. So there are times when you might get confused that is this H or is this B or is this L. What I'm trying to tell you is you can also call this as L. You can also call this as H. It hardly matters. Satya, have you understood?
Yes, sir.
Satya, is it getting confusing?
No, sir.
So Satya, are you getting confused? Are you getting confused?
No, sir. Understood.
So please do not think that please do not try to cram the formulas. So for example, if you want, I can call this as L also. It hardly matters. But what you should be very clear is that you look at the figure from the side at which it is symmetrical. You take the area of the slice and then you multiply it by the length of the side at which it is symmetrical. Any doubt?
No doubt, sir.
Now similarly, if you had to find the area of a figure like this. Now when I look at this figure from this angle, this is the area of each slice. The area of each slice is the area of a trapezium. Area of a trapezium we already know is half length, sum of the length of the two parallel sides, these sides are parallel, multiplied by the distance between them. So this is the area of a single slice. I multiply it by the length, this length, because it is symmetrical in this direction. So there any doubt?
No doubt, sir.
And therefore the volume of this figure would be equal to half A plus B into H multiplied by L. Sarthak, any doubt?
No, sir.
See, what I'm trying to tell you guys is, one second, I'll show you the questions where this would be applicable. So for example, I just go through this sheet with you, then you'll have to do this on your own. So for example, if we look at this figure, I want to find the volume of each prism. Now this is the area of each slice. Satya, can you see this now? If I look it from here.
Yes, sir.
So this is the area of the cross section. The area of cross section is half base into height. Any doubt?
No doubt, sir.
Incidentally, in this question, they have already given us the area of cross section. You just have to multiply it by this length. Any doubt?
No doubt, sir.
Again, in this figure, they have given you the area of cross section. You just multiply this area of cross section by the length. Any doubt?
No doubt, sir.
Sarthak, any doubt?
No, sir.
Here also the area of cross section is this, multiply it by length, you will get the answer. Here also area of cross section is given, multiplied by length, you will get the volume of the prism. Any doubt?
No doubt, sir.
Now the PDF that I had sent you is a bit of an issue. So this page 2 is actually page 1. This is page 2. Have you guys understood?
Yes, sir.
Sarthak, have you understood what I said?
Yes, sir.
So actually this is page 1. This would be page 2. And then it is okay. Page 2, this would be page 3. This would be page 4. Guys, any confusion?
No, sir.
This would be page 5. This is how you have to do this. So we have understood page 1. Again, when we come to page 2, again, simple questions are there. They are not very tough questions because they have already given you the area of cross section. The area of cross section is 8 into 4 multiplied by this. So 8 into 4, you calculate, multiply this cross section with this end. So any doubt?
No doubt, sir.
Again, if you look at this half base into height, this is half base into height. This is what you will be writing here. You will find the area of cross section, multiply this with h. This is 7. You will find the volume. Area of cross section, area of a circle. This is pi r square. Multiply this with 11. You will find the volume. Sarthak, any doubt?
No, sir.
See, and that is what I was trying to understand in the beginning of the lecture. If you guys are comfortable with finding the area of these figures, if you are comfortable in finding area of these figures, then all that you need to do is just multiply the area of the cross section, which we have called the slice, area of slice. You just need to multiply this with this length. Have you guys understood?
Yes, sir.
Mr. Sarthak, any doubt?
No, sir.
So the logic is pretty obvious. Let me show you page number 3. Here also, they have given you the area of cross section, just multiply it with this side. Area of cross section is given, multiply by side. Area of cross section is given, multiply by side. So any doubt?
No doubt, sir.
So for example, when we look at these figures, area of cross section, multiply by side. Area of cross section, multiply by side. Area of cross section, multiply by side. Any doubt?
Sir.
In this question, the area of cross section is pi r square. The mistake that the Timo has done is that instead of finding the radius, he has taken the diameter. Any doubt, Mr. Sarthak?
No, sir.
Mr. Satya, any doubt?
No doubt, sir.
So they are, once you understand the logic, questions are simple. Again, now this is a bit, this is also an easy question, just a bit of twist. Each of these prisms has a volume of 5 centimeter cube. Find the value of x. So for example, here, the area of cross section would be 4.2 into x. Multiply this with 18.6. You will get the volume, which is 335. Any doubts, Satya?
No doubt, sir.
Then you find the value of x. In second question, you want to find the area of this cross section first. This will be equal to half base into height. Multiply this with this 24.5. This is the volume, and the volume is equal to 335. Calculate this value of x. Sarthak, any doubt? Mr. Sarthak, any doubt?
No, sir.
So again, if you look at this, the area of this cross section would be pi into x square. This multiplied by 23.6 would be equal to 335, and then you calculate the value of x. And that is why what I am suggesting is that you will need to calculate using calculator divided by pi into 23.6. Basically, you will find the value of x square, and then to find the value of x, it would be square root of whatever value you find here. Satya, any confusion?
No, sir.
Mr. Sarthak, any confusion?
No, sir.
Now, try to do this question on your own. I'll give you a hint. The hint is that density is equal to mass per unit volume. Have you guys understood what I've said?
Yes, sir.
Yes.
Any doubt?
No doubt.
So first you will have to find the volume of the gold bar. The volume of the gold bar, how do you find it? You find it by multiplying the area of cross section with this length. Satya, any doubt?
No doubt, sir.
You will find the volume. Okay. Then what they are suggesting is that 1 centimeter cube has a mass of 19 grams. Okay. Basically what they are saying is they are giving you the density, if you have understood. The density is 19 gram per centimeter cube. Have you guys understood?
Yes, sir.
Sarthak, have you understood?
Yes, sir.
If you don't want to look at density, then also it is fine. Just find the volume. You will find the volume. Then you know that 1 centimeter cube weighs 19 gram. Once you have found the volume, you can find the mass of this slab. Have you guys understood?
Yes, sir.
Any confusion?
No, sir.
No, sir.
So just do the question till here, till you find the mass. The C part is optional because I suspect you won't be able to do the C part. Try to do this. If you are not able to do this, then we'll discuss. Mr. Sarthak, Mr. Sarthak. Mr. Sarthak, Mr. Sarthak.
Yes, sir.
Yes, sir.
Any confusion till here?
No, sir.
No, sir.
So Satya, the trick is that find the area of the slice. So for example, if this is a square, the area would be side square. If this is a cube, then the area would be length into breadth. If the slice is a right angle triangle, the area would be of the slide would be half base into height. If it is a trapezium, if this is B, this is L, this is H, then the area of the slice would be half L plus B into H. Multiply this cross section with the length of the figure. Satya, any doubt?
No doubt.
You guys can start doing the questions. Yeah? Satya, you want to ask any question?
No, sir.
Sarthik, any confusion?
No, sir.
Just remember, this is page 1, this is page 2, then page 3, page 4, page 5, and use calculator to do the questions. Any doubt till here?